Today we are going to talk about voltage drops in series circuits. Kirchhoff's law states that the sum of voltage drops in a series circuit is equal to the source voltage. Today we're going to look at a simple series circuit and see how Kirchhoff's law works. Here is a simple series circuit with two resistors and a 6-volt battery source. The resistor R1 is 1800 ohms and resistor R2 is 3300 ohms. And again, the voltage is a 6-volt DC battery. We are also going to build the circuit on the trainer in the lab, and we will take measurements using a multimeter. In a series circuit, the total resistance is equal to the sum of the individual resistance values. So R total will be equal to R1 plus R2. In this case, our 1800 ohms plus 3300 ohms will equal 5100 ohms. And here is our circuit built on the breadboard. It's a little too small to see the resistor color code values, but resistor R1 is at the top and R2 is at the bottom of the circuit trainer. And again, using Ohm's law, the current in the circuit is equal to the voltage divided by the resistance. And in this case, it would be 6 volts divided by the total resistance of 5100 ohms, giving a current value of 1.2 milliamps. Using Ohm's law for series circuits, the total current is equal to the total voltage divided by the total resistance. The fact that in a series circuit the current is the same throughout all the components, because there is only one path for current to flow, will enable us to compute the voltage through the various resistors. So the current through resistor 1, we're going to call it I1. The current through resistor 2 is I2. And these are all equal to the total current. And again, using Ohm's law, we can now find the voltage dropped across the individual resistors. The voltage dropped across resistor 1 is going to equal the current through resistor 1 times the resistance. Similarly, the voltage dropped across resistor 2 is equal to the current through resistor 2 times the resistance of resistor 2. Adding together our values of 2.12 volts and 3.96 volts, we get a total of 6.08 volts, which rounds out to 6 volts. Here we have our meter set to measure the voltage across R1, and it is equal to 1.932 volts. Here we are measuring the voltage across resistor 2, and it is 3.746 volts. And again, the sum of voltage across R1 and R2 should be equal to 6 volts. Now we do have some differences with individual resistors, but here is our total voltage showing 5.78 volts, which is close to 6 volts, again allowing for discrepancies in the resistors. Again, Kirchhoff's law states that the sum of the voltage drops in series circuit is equal to the source voltage.